Today I am going to discuss you Organic Chemistry part of National Standard Examination in Chemistry 2012-13, which was held on 24th of November 2012. In this paper there are 80 questions. इसमें 80 क्वेश्चन है जिसमें 34 क्वेश्चन ऑर्गेनिक केमिस्ट्री के हैं. यू कैन थिंक द इंपॉर्टेंस ऑफ ऑर्गेनिक केमिस्ट्री इन एनी एग्जामिनेशन. जो पहला क्वेश्चन इन्होंने पूछा हुआ है, that one is the structure given below represent. इसमें एक स्ट्रक्चर बना हुआ है और स्ट्रक्चर है OH CH2 again a phenyl group OH CH2 ये स्ट्रक्चर बना हुआ है एंड पूछा हुआ है द स्ट्रक्चर गिवन बिलो रिप्रेजेंट्स. फर्स्ट ऑप्शन इज PVC. फर्स्ट ऑप्शन इज PVC. सेकंड ऑप्शन इज नायलॉन 6. नायलॉन 6. सेकंड इज आइसोप्रीन रबर. आइसोप्रीन रबर. लास्ट इज बेकालाइट. लास्ट इज बेकालाइट. First PVC. PVC means polyvinyl chloride. This is vinyl chloride. Again another vinyl chloride. When they polymerize, they form polyvinyl chloride. Polyvinyl chloride. Nylon 6,6. Hexamethyl diamine on reaction with adipic acid. Adipic acid loses a water molecule and the polymer which is formed, the polymer which is formed by this reaction is nylon 6,6. This polymer is nylon 6,6. Here 6 carbon and this particular part also है 6 carbon. इसलिए इसका नाम दिया जाता है nylon 6,6. And third जो पूछा हुआ है isoprene rubber. This structure is isoprene. And when this combines with another isoprene, polymerize to form this type of structure, and this is the isoprene rubber. But last is the bakelite. The bakelite is formed by reaction of phenol and formaldehyde in presence of any acid. Due to plus and nature of OH group, ortho and para position are electron rich. Formaldehyde have oxygen, attacks over this proton, form CH2 OH plus, that is generation of electrophile, and this electrophile will attack over the ortho and para position of phenol, ortho and para position of phenol, and combine to form this type of structure CH2 OH, CH2 OH. Here again CH2 OH. Medium of this reaction is acidic. This base attacks our proton, remove water molecule and new carbocation is formed. New carbocation is formed. Here again, new carbocation is formed, and here again, new carbocation is formed. And another phenol molecule, ortho position attack over this type of carbocation and polymerize to give bakelite as a product. So this structure is the bakelite. The formation of bakelite can be observed by reaction of phenol with formaldehyde in presence of acid. So ये structure हो गया bakelite. Second question मैंने पूछा हुआ है, which isomer of xylene is dimethyl substituted benzene. This methyl group may be at ortho position, may be at meta position, may be at para position. So there are three isomers of xylene. First is orthoxylene, second is metaxylene, and third is paraxylene. So there are three isomers of xylene. The question is, which isomer of xylene can give three different monochloro derivatives? In this question, they want to ask chemically different hydrogen in xylene. If you carefully analyze, these two hydrogens are same. So, one chemically different hydrogen and these two hydrogens are same. Second chemically different hydrogen. If you replace this hydrogen with chlorine, you will get 1-chloro-2,3-dimethyl. Here again 1-chloro-2,3-dimethyl. But at this position you will get 3-chloro-1,2-dimethyl. Sorry, 4-chloro-1,2-dimethyl. Here again 4-chloro-1,2,3,4, 4-chloro-1,2-dimethyl. But in this case, this hydrogen and this hydrogen are chemically different. The position of this hydrogen and this hydrogen are same, but hydrogen present over this carbon are again different. When you analyze this part, hydrogen present over all these carbon are chemically same. If you replace this hydrogen with Cl, you will get 2-chloro-1,4-dimethyl. Here again 1, 2, 3, 4. 2-chloro-1,4-dimethyl. Here again 2-chloro-1,4-dimethyl. Again 2-chloro-1,4-dimethyl. The question is, which isomer of xylene can give three different monochloro derivatives? First option is paraxylene, second metaxylene, third orthoxylene, and D is the xylene cannot give monochloro derivative. Then your answer will be metachloroxylene. The next question is carbocations. This one, carbocation, carb anion, free radicals, and radical cation. This is radical. If you remove this bond, this is the radical cation. Are reactive carbon intermediates. Their hybrid orbital respectively are. They have asked the hybridization. And first option is sp2, sp3, sp2, sp. Second option is sp3, sp2, sp, sp2. Third option sp2, sp2, sp3, sp. And fourth sp2, sp2, sp and sp3. To find out hybridization of any atom, you have to count the number of sigma bond and lone pair. If the number of sigma bond and lone pair are 2, that means hybridization will be sp. If this number comes to 3, hybridization will be sp2. And if number is 4, then hybridization will be sp3. So for general, you can just count the number of sigma bond and lone pair and decide the hybridization of any atom. So in this case, there are 3 sigma bonds. So and no lone pair. So hybridization of this carbocation will be sp2. For this negative charge will be considered as a lone pair. So 1, 2, 3 and 4. So hybridization of this carbon will be sp3. This 1, 2, 3. So again hybridization of this carbon will be sp2. And in this particular pass there are only 2 sigma bond. So hybridization of this carbon will be sp2. Sorry, sp. Hybridization of this carbon will be sp. So the answer will be first sp2, sp3, sp2 and sp. The next question is the electronegativities of acetylene. Acetylene is H, C, triple bond C and H. The electronegativities of acetylene, ethylene, CH2, double bond, CH2 and ethane, CH3 and CH3 are in the order. First option is ethane greater than acetylene greater than ethylene. Second, acetylene greater than ethane greater than ethylene. Third, ethylene greater than acetylene greater than ethane. And fourth is acetylene greater than ethylene greater than ethane. That means they change only this particular part and arrange in question B. When you carefully analyze the hybridization of this carbon, it is sp. Analyze the hybridization of this carbon, it is sp2. And hybridization of this carbon, it is sp3. So electronegativity of this carbon is highest. Therefore, the answer will be first triple bond, followed by double bond, followed by single bond. Greater is the S character, higher will be the electronegativity. In this particular part, 50% S character is there. In this particular part, 33% S character is there. While in this particular part, there is only 25% S character. So answer will be the D, acetylene followed by ethylene followed by ethane. Next question, a catalyst accelerates a rate of primarily by stabilizing the. First option is intermediate, second option transition state, third option substrate and fourth option is the product. It means for any chemical reaction, substrate is present here, some activation energy, then intermediate, then product. It may be possible that some chemical reaction may take place at one step without any intermediate. So if intermediate is formed, then position of intermediate will be here. But if intermediate is not formed, then reaction will just give to product. So a catalyst accelerates a reaction primarily by stabilizing the. First option is intermediate. It is wrong because many chemical reaction may take place without the formation of intermediate. Second is the transition state. Yeah, this is the correct answer because in some cases, if catalyst is used, this activation energy is decreased. And if this activation energy is decreased, then rate of reaction will be increased. And this activation energy will only decrease if transition state get stabilized. And third is state and fourth is the product. So the answer will be transition state. Catalyst lowers the activation energy, that means it stabilizes transition state. Next, the number of transition state in a unimolecular nucleophilic substitution SN1 reaction is. First option is 1, second 0, third C, third and fourth option is the 2. So first, for a general SN1 reaction, substrate is alkyl halide or alcohol. First, leaving group goes out, there is formation of carbocation and nucleophile attack over this carbocation to finally give RNU as a product. This is the simple reaction of SN1. when you make a reaction accordingly, here substrate Rx is there, it will take some activation energy and form carbocation, and finally nucleophile will attack over this carbocation and R and U as a product is obtained. So first activation energy, that means first TS, and second activation energy, it means second TS. So in this case, in case of SN1 reaction which do not proceed with rearrangement, in that case two transfer states are formed. But if rearrangement will take place, in that case maybe the TS increase. So general SN1 reaction give 2 TS. So therefore answer will be 2. Next question. The dipole moment of halo compounds are in the order. They have given 4 substrate with rearrangement. First is cis 1,2-dichloro. Second is dichloromethane. And third is trichloromethane. And last is the tetrachloromethane. First option is first greater than second, greater than third, greater than fourth. And second option, this one, first greater than second, greater than third, greater than fourth. And third option, first greater than second, greater than third, greater than fourth. And last option, first greater than second, greater than third, greater than fourth. To find out dipole moment, you look the basic concept, basic definition of dipole moment, that is charge into distance. For a symmetrical molecule, if you want to prepare a regular tetrahedral molecule, you must place central atom at this particular position and atoms just alternate to each other. In case of simple methane, this one is carbon, hydrogen, hydrogen, hydrogen and hydrogen. Make a regular tetrahedral geometry by joining hydrogen with this carbon. For a regular geometry, the dipole moment will be 0. So in case of tetrachloromethane, the dipole moment will be 0. But in these three cases, it will have some fixed dipole moment. In this particular case, this one, and in this particular case, this chlorine is also replaced with the hydrogen. Here, 2 chlorines withdraws electron, but in this case, 3 chlorine withdraws electrons. 2 chlorine, here hydrogen donates electron because electronegativity of hydrogen is 2.1, electronegativity of carbon is 2.5, and electronegativity of chlorine is nearly 3.5. So, in case of dichloromethane, due to electronegativity difference, this observed dipole moment will be 1.6 Dibber. In this particular case, 3 chlorines withdraws electron. So due to additional withdrawal of electron from this chlorine, dipole moment decreases, and this comes to 1.04 Dibber. In this particular case, additional carbon is there, so distance increases, and as the distance increases, dipole moment also increases, and this comes to 1.90 Dibber. So answer will be first cis, then dichloro, then trichloro, followed by last tetrachloromethane, and option will be A. following information is not provided by a reaction mechanism? Just I have given the reaction of SN1, RX, halogen goes out, carbocation is formed, then nucleophile attack over this carbocation and RLU is observed. If you mean a reaction coordinate, then this type of structure is observed. So the question is, which of the following information is not provided by a reaction mechanism? First option is, which intermediate and transition state are formed? By observing this reaction coordinate, you can easily observe these two transition state and this carbocation, that is reaction intermediate, is observed in this reaction. So it is correct. Which step is slowest, or which is the slowest step? You can observe the activation energy of this one is higher as compared to activation energy of this one. So therefore this is the RDS step. So this information is also given. Which energy content of the reacting intermediate, reacting species? This information is not given because this is the part of physical chemistry. What is the energy content? Means fixed value. It may be 100 kilojoule for one reaction, it may be 200 kilojoule for another reaction, it may be 500 kilojoule for another reaction. The energy content is not provided by any reaction mechanism. And last is the which bonds are formed and which bonds are broken. By this particular reaction, you can easily observe this particular bond is formed and this particular bond is broken. So reaction mechanism does not provide about the energy content of reacting species. Next is the tolerance reagent is. Tolerance reagent is. They have given first option Ag2O, second option silver ammonium nitrate Ag NH3 2 plus, third Cu2O, and fourth CuOH4 2 negative. And we know that tolerance reagent is the silver ammonium nitrate. So answer will be B, Ag NH3 twice H plus. Next question is, the RS designation for the following stereoisomers of 1,3-dibromo-2-methyl-butane is. They have also given the structure CH2 Br H CH3 Br H and CH3. This one, first carbon, second carbon, third carbon, fourth carbon. So 1,3-dibromo-2-methyl-butane. So they have asked the question, the RS designation for the following stereoisomer of 1,3-dibromo-2-methyl-butane is. So look for RS nomenclature over second carbon. This is hydrogen, this is carbon, this is carbon, this is carbon. So this have last priority. This carbon is attached with bromine and carbon, but this is attached to hydrogen, hydrogen and hydrogen. Here hydrogen, hydrogen and bromine. So this one is having highest priority. So in first, second, third, movement is anti-clockwise, looks as S, but you have to change one part because hydrogen present over this carbon is above the plane. First you bring it to below the plane. So inversion in configuration take place and this S will become R. At this particular position, this is first, this one is second because this carbon is attached with CC, but this carbon have only HHH. So first, second, third. This also looks as S. Similarly, one change has to take place and so S become R. So configuration will be 2R, 3R. So they have given the options. First, 2S, 3R. Second, 2S, 3S. Third, 2R, 3R. And fourth, 2R, 3S. So the correct option is 2R and 3R. Next, they have given question on amino acid. The question is the amino acid that cannot be obtained by hydrolysis of protein is, and they have given option A HOOC, CH2, CH, NS3 plus and COO negative. Second option is HC, CH2, COO negative, NS3 plus SH. Third option is amino acid with heterocyclic ring, CH2, CH, NS3 plus COO negative, and last is the NS3 plus CH2 4 times CH, NS3, NS2 and COO negative. The question is the amino acid that cannot be obtained by hydrolysis of protein is. This question is just on the basic definition of amino acid. The basic definition of amino acid is alpha amino carboxylic acid. It means same carbon is attached with NH2 group and COOH group. This particular has hydrogen and this particular part is replaced with any atom or group. And after change of this R, there are different 20 amino acids are obtained, which are naturally occurring in nature. So this is 0, this is alpha. So the basic definition of amino acid is alpha amino carboxylic acid. So you have to observe only the alpha amino carboxylic acid. Which amino acids are alpha amino, and if alpha amino carboxylic acid is not present in this particular molecule, that means they are not the amino acid. It may be possible that this base abstract this proton or abstract proton from any acid present in reaction container and form this type of compound NS3 plus H and COOH. So amino acid have two acidic hydrogens, first at this position and second over this position. It is experimentally observed that pKa value of this NS3 plus is nearly 9 and pK value of this particular acid is nearly 2. So if amino acids are present in any medium which have pK value lower than 2, therefore in this particular medium this H and this H will intact. So amino acid exists in this particular form in pH less than 2. But if amino acid is present in a medium in between 2 and 9, this hydrogen goes out, and in that particular part the existence of amino acid will be like this. But if medium of amino acid is higher than 9, in that particular case this hydrogen and this hydrogen both goes out, and that particular part the existence of amino acid will be like this. So amino acid may exist in this particular form and this particular form. For giving a simple concept, we only define alpha amino carboxylic acid, but no alpha amino carboxylic acid or amino acid exists in neutral form. Amino acid always exists in the charged form. If pH less than 2, this form, pH in between 2 and 9, this particular form, and if pH